Hello dear students, I am discussing high weightage test 2 most incorrect questions done by students. This test 2 was related to telescopic sum. So before I start solving those questions, before I start discussing those questions, I will like to tell you few key ideas that are must to know before you start solving the questions of high weightage test 2, not only incorrect but all any other question. Okay, so what are those ideas? Please listen carefully. The first idea would be that whenever we have to find the sum using telescopic sum, okay, the key idea of telescopic sum is that your every term tr should be written as difference of two functions, maybe f of r plus 1 minus f of r, or it could be f of r plus 2 minus f of r, something like this. So every time we have to write your rth term like this, and then you add all these terms, and you will see when you are writing all these terms as a difference of two functions, there will be cancellation happening. Few terms will remain in the beginning, few terms will remain in the end, and you will get the sum. Okay, now this is the idea actually. Let me show you by writing it. So T1 will be F2 minus F1, T2 will be F3 minus F1, F2, and so on. And Tn will be Fn plus 1 minus f of n. If you add them, your sum of n terms will be, you can check, F2 will cancel, F3 will cancel, Fn will also cancel here. So you will be just left with f of n plus 1 minus f of 1. Please be careful. Sometimes if your difference suppose is like this, then you will see your difference, your cancellation actually will not happen immediately. In this case, it will be f of 3 minus f of 1, f of 4 minus f of 2, f of 5 minus f of 3, and so on. F of n plus 3, f of n plus 2 actually, okay, minus f of n. You can see this f3 is not cancelling here, it is cancelling here. So f4 will also cancel here, f5 will cancel here, and so on. So you can see two terms will not cancel at all. If that is so, your two terms will not cancel here also. In this case, your sum would be actually the two terms fn plus 2 and f of n plus 1 will remain, minus f of 1 and f of 2 will remain from here. So that is the key idea behind telescopic sum. But when we are doing questions, there are multiple ways to split your TR as difference of two functions. And what are those two things? So I will be first telling you few important things that you must know. The first one is, when you are given your TR as reciprocal of product of few terms in AP, like A1, A2, A3. I will take till A3 only. And this is T1, not TR. This is just T1. And similarly, your T2 will be 1 upon A2, A3, A4, and so on. In such case, how to split? Please understand, I will be telling you how to split it, because A1, A2, A3 are in AP. This is when A1, A2, A3, and so on, they form an AP. If they are in AP, your difference of A3 and A1, difference of A3 and A1 will be 2 times common difference. Okay, and it is A1, A2, A3. If you apply same idea here also, you take the difference of two extreme numbers A4, A2, it will also be 2D, and this will be A2, A3, A4. In this case, 1 upon 2D and A3 upon this will give you A1, A2 minus 1 upon A2, A3. Okay, similarly here also you can write 1 upon 2D, and that will be 1 upon A2, A3 minus 1 upon A3, A4. If you keep adding them, you can see some telescopic sum is being formed. This term will cancel this will cancel the next, and so on. So this is one of the idea when your terms of AP are multiplied and they are in reciprocal. But dear students, there is one very standard category of questions when your terms are there and terms of AP are there, they are multiplied, but they are not in denominator, not in reciprocal, but they are like this: A1, A2, A3. It could be A4 also, and so on. Now, in this case, to split this as two functions, to write it as a difference of two functions, the idea would be that you will be multiplying A1, A2, A3, A4 with A5 minus A0. The next term after A4 will be A5. The term before A1 would be A0. You can just observe the pattern and you can anticipate what should be A0. So this will be your zeroth term, you can say. Although in sequence we say always your first term is the first, the beginning starts with the first term, but in this case you can just assume what could be zeroth term, and the difference will be 5D. Okay, so by doing this thing and writing as a difference of 2, you can see you will be getting difference of two functions, and if you apply the same thing for T2, T3 and so on, you will get telescopic sequence, telescopic sum. Okay, I am not doing completely. I think this you must have done, you might have done in your various classes, but I'm just telling you, I'm refreshing those ideas that are must to know before you do these kind of questions. Okay, so that is second thing. Now coming to third thing is that we will be given some fraction. We will be given TR as some fraction, maybe quadratic or cubic, or maybe sometime irrational terms also. Okay. So this will be, let's say, FR, 1 upon FR, or maybe some terms in the denominator also. You will be trying to write this as a difference of two fractions. You can call this as a partial fraction, or you may use some method of rationalization. Okay, there can be rationalization, one of the idea. Okay, there can be another idea as partial fraction. Okay, sometimes if some factorial terms are given, then also you will think how we can split. Basically the idea is split them into two, sometimes more also, fractions, and those fractions should be such that when you apply telescopic sum, alternate terms should cancel, maybe immediately or maybe after some time. See, if this question is based on telescopic sum, and in fact if you are given, you are asked some sum that is not based on AP, GP, AGP, I think it has to be done with the help of telescopic sum. And telescopic sum, if this is based on, it has to be converted into this kind of difference of two functions. Without that you cannot do this kind of summation. So you just have to crack that idea. Sometimes it is easy to, sometimes it is not easy to. I am only sharing some of the ideas that can help you to do that thing. Okay, so this is one thing. And then fourth, I will say tan inverse. There is a property, tan inverse x minus tan inverse y is equal to tan inverse x minus y upon 1 plus x. This is valid when x into y product is greater than minus. Okay, so this property is one very important property, and we have seen most of the questions of telescopic sum and of inverse trigonometry are based on this. And not only JEE Mains, you will see it is also important for JEE Advanced, and some other exams also it can come, but let's stick to JEE Mains. So this is one very important thing. Okay, now the one more thing I will talk about, as we always said telescopic sum, but we can also say telescopic product. What is telescopic product? In this case, your terms would be written as f of r upon f of r plus 1, and you will be taking their multiplication. R will be starting with 1 going till n. If you keep writing these terms, the pi sign means continued product. So you will see this, they will cancel each other. F1 upon F2, F2 upon F3, F3 upon F4, and so on. You can see this F2 is cancelling this, F3 is cancelling this, F4 will be cancelling the next one. So this term is remaining and there will be one term in the end that will remain. So your this continued product or telescopic product, you can say, will be found that way. Sometimes it is quite possible your product will not be, they will not be cancelling immediately after, rather they will be cancelling, maybe this will be cancelling here, this will be cancelling here. That you have to look at this carefully, then only you should cancel them. I have seen questions in JEE Mains, JEE Advanced, previously some NSE exam or such exams, there they have given intentionally questions where cancellation is not happening immediately. So you have to confirm, you have to verify whether actual cancellation is happening immediately or maybe one term after or two term after. That is very important to understand. Okay. So let's start doing some questions which are given in this session actually. So my first one is m is equal to summation 1 upon under root k plus under root k plus 1. Okay, to find this m, I think the simplest method would be just do the rationalization, and to do the rationalization it will be under root of k plus 1 here minus under root of k here, and when this multiplied in the denominator will just give you 1. Now k is starting with 1 going till 120. Now if I write all these terms starting with 1, it will be root 2 minus root 1 first term, then root 3 minus root 2, then root 4 minus root 3, and so on. The last one being root 121 minus root 120. Now you can see this cancellation is happening immediately after this. So this root 2 is getting cancelled here, root 3 is getting cancelled here, root 4 will be cancelled here. So root 1 is remaining. So root 120 will remain here. This 120 will cancel with one term before it. So what are we left with now? Just that root 121, that is 11, and minus 1, so it is 10. So this value of m is coming out to be 10. Now they are also asking the value of n. Now this n, arc means tan inverse. Arc means tan inverse. Okay. So as I told you, in this kind of questions, always it is based on the property tan inverse x minus tan inverse y, and you have to understand how this can be done. I will do it here. Summation, I can write this as tan inverse. I can write denominator as 1 plus k into k plus 1, and here it is k plus 1 minus k. So we can write this as summation tan inverse k plus 1 minus tan inverse k, and we have created successfully a telescopic series. If you start putting k is equal to 1, 2, and so on, okay, and we have to go till infinite. My first term will be tan inverse 2 minus tan inverse 1, okay, plus tan inverse 3 minus tan inverse 2, and so on. And the last, although we could have written that way, tan inverse n tending to infinity, but this way also I can write, although it is looking little weird, but for sake of simple calculation we can write that way. So you can see this tan inverse 2 will cancel here, tan inverse 3 will cancel here, this term will cancel from the previous term, and you can see only two terms are remaining, the tan inverse 1 and this last one. Tan inverse infinity, or rather tan inverse, let me not write that way, I am feeling a bit guilty when I am writing that way, n and n minus 1. Okay, and when n is tending to infinity, I can write this as a pi by 2, because tan inverse infinity is pi by 2 minus tan inverse 1, that is pi by 4. This becomes equal to pi by 4. Okay, they are saying limit k equal to 1 to infinity. I think that will be pi by 4. Okay, and then this 4n upon infinity value will be, I think, 1. The point is 10 comma 1. Now you can check which option is satisfying it. A option, x plus y is 11, that is correct. X minus 10y also correct. 10 minus 9 is 1, also correct, and 10 minus 1, 9 is also correct. And they are asking the correct option only. I think they all are correct. Maybe there is some error in this. They all are correct. Which option they have given? C. They have given and what are the values? M is 10 and N is, other point is 1. Yeah, correct. So checking the option, I think all the options are correct. Some problem is there, but I think this all the options are matching as of now. Okay. Now coming to the next question. Let a sequence be defined by Fibonacci numbers f0, f1 and so on. Find the value of infinite sum fn upon fn minus 1, fn plus 1. Now dear students, once again, as I told you, we will try to split as two partial fractions. Okay, I can write fn. You know, fn plus 1 is equal to fn plus fn minus 1. I think we know it otherwise also, and they have given in the question also. Fn plus 1 will be fn plus fn minus 1. If I use this fn here, it will be fn plus 1 minus fn minus 1 upon fn minus 1 fn plus. This can be written as summation 1 upon fn minus 1 minus 1 upon f. Okay, if I start putting the values of n, and it is starting from 2, this will be equal to, let me write it here, 1 upon f1 minus 1 upon f3. It is not 2, the difference is of 2, plus 1 upon f2 minus 1 upon f4 plus 1 upon f3 minus 1 upon f5, 1 upon f4 minus 1 upon f6 and so on. I have intentionally written more number of terms here. You can see there is no cancellation happening with this. 1 upon f3 is cancelled here. 1 upon f4 is cancelled here. Then 1 upon f5 will be cancelled, I think maybe here. So you can see these two terms are intact. They are not getting cancelled with any one of them. If this was a sum of n terms, so you can very well imagine if first two terms are remaining, that is 1 upon f1 and 1 upon f2. In the end, if it was n terms, okay, so it would have been 1 upon fn and 1 upon fn plus 1. That will not be cancelled with anyone. Okay, because this is going till fn plus 1. If I take n from 2 to n, so it will be going like this. Okay, but because they are saying n is infinity or n tending to infinity, these fn plus 1 terms will be going to infinite, and you can see why they are infinite, because my first term is 0, and then they have said f1 is 1, and every next term will be sum of previous two terms. That will be 1 here, then 2 here, then 3, then 5, then 8, then 13, then 21 and so on. So you can see as your n becomes more, the terms becomes large and very large. So as n tending to infinity, we can claim these two will be 0 and your first term is 1 and second term is also 1. See, this was f0, this is f1. So these two will be 1 and minus 0. This will become equal to 2. So answer of this question becomes B. Okay, so dear students, please practice all these questions because they are very highly probable questions for JEE Mains. Telescopic sum will definitely come. It has never happened that telescopic sum questions are not coming. Every year, every shift they are giving. Maybe in your paper it may not come, but there are high chances that it will come. At least 50 or 60% papers, this will definitely come. Now sum of first n terms of a series is Sn is equal to n plus 1, n plus 2, n plus 3. Now you can see n plus 1, n plus 2, n plus 3. If I write, just 1 minute, sorry, they have given Sn, and Tr is the rth term of this series. Okay, so if we are looking for Tr, I think I can say this will be Sr minus, I can say Sr minus Sr minus. Okay, Sr minus Sr minus 1 will give you Tr. Now Sr would be, if this is Sn, this will be R into R plus 1, R plus 2, R plus 3, minus this will be R minus 1 into R, R plus 1 and R plus 2. You can take, I think, R plus 1, R plus 2 common, and R plus 3 minus this thing will give you 4 times R into R plus 1 into R plus 2. This is my rth term. And then they are asking the value of 1 upon TR, sigma 1 upon TR. So we are looking for summation 1 upon, and this 4 will cancel this also. It is R into R plus 1 into R plus 2. So you can see it is the same thing which I told you in the beginning. If you start writing these terms by putting R is equal to 1, first one will be 1 upon 1 into 2 into 3, then 1 upon 2 into 3 into 4 plus 1 upon 3 into 4 into 5 and so on. Now I told you how to split them as a difference of 2. We will be taking the difference of these two terms because they all are in AP 1 2 3 or 2 3 4 or 3 4 5. If you take the difference 3 minus 1 upon 1 into 2 into 3, here it will be 1 upon 2 plus 4 minus 2 upon 2 into 3 into 4 plus 5 minus 3 upon 3 into 4 into 5 and so on. And this we have to take till infinite. Okay, let me use this space here. This will be equal to 1 by 2 outside. 3 upon this thing will be 1 upon 1 into 2. 1 upon this thing I can write this as 1 upon 2 into 3. Then plus this will be 1 upon 2 into 3 minus 1 upon 3 into 4, then 1 upon 3 into 4 minus 1 upon 4 into 5 and so on. You can see the terms are getting cancelled. Terms are getting cancelled. I think 1 upon 2 into 3 is getting cancelled. 1 upon 3 into 4 is getting cancelled. All the terms are getting cancelled, and they are cancelled immediately after, means after the next term itself they are getting cancelled. So if this term is remaining, there will be one term that is remaining here also, but because my R is going till infinity and these numbers will be in the denominator, so you can say this will be tending to 0. So it becomes 1 upon 2 into 1 upon 2 minus 0, that has to be equal to 1 by 4. Okay, so answer of this question is, let us say D. Yeah, correct. Now coming to this question, cot inverse. I think this is same question that we did the first question, because cot inverse you can write it as tan inverse 1 upon 1 plus n plus n square. Okay, and the 1 you can write it as n plus 1 minus n. So this will be written as tan inverse n plus 1 minus tan inverse and summation of this thing. So if you put n is equal to 1 to infinity, I think this will be same thing. I can write it directly. You will remain, or let me do it completely, tan inverse 2 minus tan inverse 1 plus tan inverse 3 minus tan inverse 2 and so on. You can see this tan inverse 2 it gets getting cancelled here. Tan inverse 3 will be getting cancelled here. So only tan inverse 1 will remain here and tan inverse infinity remain there. So pi by 2 for tan inverse infinity and tan inverse 1 pi by 4. This will become equal to pi by 4. So answer of this will be A. Now this question, we are given Sn is equal to 1 upon 2 plus 1 upon 6 plus 1 upon 12 and so on up to n terms. So first part is to find S49. Now dear students, try to understand this is 2, 6, 12 and so on. Now, if you look at the difference between these two, you will see it is 4 here and then it is 6 here. Okay, I feel there should have been one more term, then it will make more sense. I think that would have been 20 here. The difference will be 8. So you can see the difference of two consecutive terms are in AP here. 10 minutes. 10 minutes. So 4, 6, 8 will be the difference if you take that way. Okay, and if difference of consecutive terms in AP, then your general term R has to be a quadratic in R. You can take this as a AR square plus BR plus C. It has to be a quadratic in R. And if you write R is equal to 1, 2 and 3 and you can find these values A, B, C, your TR will be coming out to be R square plus R. You can R as 1, then it will give you 2, RS2 will give you 6, RS3 will give you 12, and so on. Dear students, there is another method also, that is called method of difference. You write your sum n as 2 plus 6 plus 12 plus 20 and so on. Okay, you write it again after difference, after shifting it 1 towards left, so 2 plus 6 plus 12 and so on, Tn minus 1 plus Tn. And if you take the difference, here it will be 0, here it will be 2 plus 4 plus I think 6 plus 8 and so on. Here also you will be getting some difference, Tn minus 1, and in the last minus T. Okay, this way you can find Tn very easily. Okay, you can check, because I have shifted the entire thing by 1. So this has to be n plus 1th term if you count from the starting. If you count from the starting, this will be n plus 1th term. These are n terms, and this Tn is actually equal to 2 plus 4 plus 6 and so on, n terms. And you can see it's a AP, sum of n terms. You can find n by 2 into 2a plus n minus 1 into d. I think that is coming out to be, and 2a means it is 2 into 2, 4, I think. A is 2. So it will be coming out to be n into n plus 1, you can check. Okay, and n into n plus 1 is satisfied for every term. Okay, now I will go to the next slide because there is no space here. Answer we have seen, but it's okay. So what is my Sn? Sn is actually sigma of 1 upon r into r plus. The value of r is starting with 1 and going till n terms. Okay, so here we will be writing these two as split 1 upon r minus 1 upon r plus 1. If you start putting r is equal to 1, you get 1 minus 1 upon 2, then 1 upon 2 minus 1 upon 3, and so on. For nth term, it will be 1 upon n minus 1 upon n plus 1. So you can see the cancellation is happening, and we will be getting 1 minus 1 upon n plus 1, that is n upon n plus 1. So that is the sum of n terms. Now, the next line is sum of first 7 terms of an AP is this thing. Sum of first 7 terms of AP is this thing. So S49 means it would be under root of 49, because 50 will cancel 50. So this gives you 7. So sum of 7 terms of an AP is 7, and its first term and common difference is P and minus P respectively. Very easy. We have to find the 10th term of the AP. Okay, now dear students, so sum of 7 terms means 7 by 2, okay, into 2a, so 2p plus 7 minus 1, 6 into d. I think d is given to us as minus p. First term is p, common difference is minus p. If you simplify it, you will be getting, I think, 2p minus 6p, so minus 4p, so minus 14p, I think, is equal to this. So p coming out to be minus half. We check my calculation. P is equal to minus half is correct. Okay, then what are they asking? They're asking for 10th term. Okay, so P is minus half. So first term is minus half, and common difference is minus P, that is 1 by 2. This is 0, this is 1 by 2, this is 1, and so on. I think we know A, we know common difference. So I think we can, D is half actually. So T10 we can find. It will be minus half plus n minus 1 into d. So I think this becomes equal to 4. Yeah. Answer for this question should be C. Yeah, already we have seen this answer. So there are two things here. One, telescopic sum, then AP. Okay. Coming to the next question. Find the infinite sum. Find the infinite sum of this thing. Now in this case we are given factorial, bit tricky, but I think we can do it. Please try to understand. We have to write it as a difference of 2 or 3 terms. Let's see how we can do it. So this term here, what I will do, because we know there is a property for factorial, k plus 2 factorial, you can write it as k plus 2 into k plus 1 factorial, or if needed you can also write it as k plus 2, k plus 1, and then k factorial. Okay, that is what I will be using here. If I try to write this quadratic in the numerator, okay, let me do this calculation here only. k square plus k plus 1, minus 1 actually. I can write this as k plus 2 into k plus 1. So you can see this will be k square plus 3k plus 2. Okay, for that I have to subtract, because I need k only, so I have to subtract 2k, and because I need minus 1, so I have to subtract minus 3 here. Okay, and then I will be writing k plus 2, k plus 1, okay, minus 2 times I will write k plus 2. Why k plus 2? Because there is k plus 2 factorial in the denominator. Now for k plus 2 be written, I think it should be plus 1 here. Okay, so this quadratic I have written this way, please understand. Why I have written that way? So that I will be able to simplify this k plus 2 factorial in terms of k factorial or k minus 1 factorial or k factorial. Okay, so this thing has become, you can now write directly k plus 2 into k plus 1 minus 2 times k plus 2 plus 1. If I write after splitting in 3 parts, so this upon this will be just 1 upon k factorial. You can see k plus 2 factorial can be this thing. So k plus 2, k plus 1 gets cancelled, 1 upon k factorial. For this one it will be 2 upon k plus 1 factorial, and for the last one it is 1 upon k plus 2 factorial. Okay, now you can make two telescopic series here. Please see how. Although by doing directly also it will work, but let me do it in 2 steps. So k factorial minus 1 upon k plus 1 factorial, and then minus summation 1 upon k plus 1 factorial minus 1 upon k plus 2 factorial. Okay, k will be starting with 1 going till infinity. Here also going with 1 going till infinity. Now if you write these values here 1, 2, 3 and so on, the first one will be 1 upon 1 factorial minus 1 upon 2 factorial, then plus 1 upon 2 factorial minus 1 upon 3 factorial and so on. Plus for the next one it will start, actually not plus, it is minus here. It will be we'll start with 1 upon 2 factorial minus 1 upon 3 factorial plus 1 upon 3 factorial minus 1 upon 4 factorial and so on. If you add till infinite, I think this will cancel, this will cancel, this will cancel, this will cancel, and the last term will be just 0 because we are going till infinite. So we are left with 1 here and 1 by 2 here. That will give you 1 by 2 as the answer of this question. Okay, so B is the answer of this question. I think same method is done here also. Now this question, the value of infinite product. Now dear students, very important question. Instead of summation they have given product. Now how we can deal with this? Try to understand this n cube minus 1, I can factorize it n minus 1 into n square plus n plus 1. Whereas in the denominator I can write it as n plus 1 n square minus n plus 1 sigma, not sigma, pi product. N will start with 2 going till infinity. I will split it into 2 parts, 2 product. One coming from this n minus 1 upon n plus 1 into product of this thing n square plus n plus 1, and here n square minus n. These two things I have split it into. If I start writing for first one where n is starting with 2 going till infinity, okay, here also, so if you put 2 it will be 1 upon 3 first, then it will be 2 upon 4, you put 2, and 1 upon 3, if you put 3 it is 2 upon 4, then it will be 3 upon 5. So in the numerator it is 1, 2, 3, 4, 5 and so on, and here it is 3, 4, 5, 6 and so on. Okay, that is my first product. And if I write the last term, let me write last term also. Last term would be, I think, n minus 1 upon n plus 1 and n minus 2 upon n. Okay, into the second thing. If you put n is equal to 2, here it will be 2 into 3 plus 1, whereas it will be 1 into 2 plus 1. When you put n is equal to 3, it will be 3 into 4 plus 1. It will be 2 into 3 plus 1 here. If you put n is equal to 3 and so on. The last term will be this only, n into n plus 1 plus 1, and here n minus 1 into n plus 1. Okay, you might be thinking that here I have written only just the last term, whereas here I have written two terms. There is a reason. You can see here 3 is cancelling this 3, 4 is cancelling this 4, 5 is cancelling this 5, and so on. So you can see these two terms will remain intact. So here these two terms will remain intact. This will cancel with some term before, this will also cancel with some term before. Here you can see cancellation is happening immediately in the next term. This will cancel it here, this will remain. So here this will remain, this will cancel one term before it. So what are we left with? So we are now left with, let me use this space, sorry, I am left with 1 into 2, so 2 here upon n into n plus 1. Okay, and in this second bracket we are left with n into n plus 1 here upon 2 plus 1 3 here. Okay, so because n is tending to infinity, because your limit n tending to infinity, in that case I think we know it is just quadratic upon, if it is quadratic upon quadratic, only leading term matters. Leading term matters. Although you could have written 1 plus 1 upon quadratic also, that is fine, but I think we should know this thing also, that if it is quadratic upon quadratic, then for n tending to infinity only leading term will matter. So 2 upon 3 into 1. So answer for this will be 2 upon 3. Yeah, 2 upon 3 is the answer of this question. So that is all for this test. Thank you so much. I'll be coming again with another test. Thank you. Bye.